Year 6 and happy Wednesday. Gosh, this week seems to be flying by, doesn't it? The weeks seem to be going by quicker and quicker. So here we are back with another arithmetic teaching session. So as always, make sure you've had a go and that you've got your answers there ready so that you can mark them along with me and just use them to revise any methods that you might have forgotten about. So we're going to start with question number 1, which is 4/5 divided by 5. Now, what do we know when we see a fraction divided by a whole number? What do we have to do? Brilliant, we are actually multiplying. So we know the top number, or the numerator, stays the same. What do we have to do with the bottom number, or the denominator? Brilliant. So we do 5 times 5, which is 25. Fantastic. Can I simplify Year 6? Is there a number that divides equally into 4 and 25? No, you're absolutely correct. This is as simple as we can make this fraction, 4/25. So if you've got that one, give it a neat little tick. If you've made a calculation error somewhere along the way, just pause the video now and see if you can correct that. Okay, let's have a look at question 2 then. Now, I know the children at school are getting much more confident with our percentage questions, and hopefully you are at home as well. So we want to work out 85% of 80. Now, we should be able to, by now, figure out 10% of an amount. So in this case, 10% of 80 is 8. Well done, everybody. Now, don't forget, if you want to find 10% of a number, then all you have to do is divide by 10. Okay, now if I know 10%, how could I use that to help me find 5%? What could I do? Think about the relationship between 10 and 5. What do you notice? Well done to everybody that says it's half. 5 is half of 10. So to find 5%, I just need to half 8, which is 4. Okay, I need to find 85%. So how could I use 10% now to find 80%? Well, 80 is 8 lots of 10. So I know I'm going to need 8 lots of 10%. So 8 times 8 is, well done everybody, 64. So I now know what 80% is. What do I need to do with the 5% that I worked out earlier? Well, of course, I've got to add it on so that I am totaling 85%. So I've done a little jotting here. You'll probably be able to do this mentally. 64 and 4 is 68. So 85% of 80 is 68. Now, some of you may have had a different method. That's absolutely fine if you do a subtraction. Okay, you can, depending on sort of the patterns and the numbers you can see, there's lots of different ways to solve this, and you can choose the method that you're most comfortable with. Okay, then we're going on to number 3. So we've got 0.8 times 346. Now, I'm going to use the column method over here for this one. I've set it up ready for us. We're all ready to go. I've made sure everything's lined up accurately. So I'm going to start over here with 6 times 8, which is, well done, 48. I'm going to put the decimal point in now. So 4 times 8 is 32. Add the 4, 36. 3 times 4 is 24. Add the 3, 27. Now, I could carry on and multiply everything by 0. But I know that 0 times 6 is going to be 0, 0 times 4 is going to be 0, and 0 times 3 will be 0. So actually, I'm not going to waste my time doing that just to know that everything is going to equal 0. I don't need to do that. I've already got my answer here, 276.8. So if you've got that one, give it a neat little tick. If you think you've made a calculation error somewhere, pause the video now, go back over your thinking, see if you can spot it. Okay, this brings us on to question number 4. So we're doing 9,288 divided by 9. Now, if you're not too confident with your multiples of 9, then you could write them out to help you. Okay, but hopefully most of us now are feeling a bit more confident with our 9 times table, particularly with the amount of division we've been doing at the moment, and we should feel quite confident to get started on this one. So 9 into 9 goes once, well done. 9 into 2 doesn't go, so I carry my 2 across. 9 into 28. 3 times, well done. Remainder 1, brilliant, because I know 3 times 9 is 27, so I have a remainder of 1. 9 into 18 goes twice, absolutely. 9 times 2 is 18. So we should have an answer of 1,032. Again, give that one a neat little tick. If you've made a calculation error somewhere, pause the video now, go back and see if you can spot and edit it. Okay, right, we are really making good progress with these. I don't think anybody got this one wrong earlier in the week. So let's just do a quick reminder. 1 times 1 is 1, and 11 times 8 is 88. Well done, everybody. Okay, hopefully you're feeling confident with those. Once you get your head around the fact they're not too scary and you remember the method, they're not so daunting, are they? Okay, so this next question, then we're on to our flashback now. So we've got to complete 2,688 divided by 24. Okay, right, I'm over here, I'm ready to go. If you'd feel a little bit more confident with your multiples of 24 written out, of course you can do that. Okay, you can keep going if you need to. Right, let's start then. So 24 into 2 doesn't go. I'm going to carry the 2 across now, exchange it, so it becomes 26. 24 into 26 goes 1 time with a remainder of 2. Well done, everybody. 24 goes into 28 once with a remainder of 4. Fantastic. And 24 goes into 48 twice exactly, no remainders. So hopefully you've got 112 for that one and you can give it a tick. As always, if you've made a miscalculation, do go back and do a double check. Right, so we're on to question 2. Is 12 a factor of 36? Now, what is a factor? Brilliant. We want to know if 12 multiplied by something is 36. So, can I multiply anything by 12 to make 36? Well, actually, I know 12 times 3 is 36. So therefore, because I can multiply 12 by something and it equals 36, then yes, 12 is a factor of 36. Okay, let's have a look then at question number 3. Work out the missing number. So we've got our whole here, 2,367 equals, so that means that it's got to be the same, both sides of the equal symbol have got to be the same amount. So 2,367 has got to be equal to, or the same as, 2,000 add something, add 7. Now I've used the part whole model over here, and for some grown-ups at home this might be new, but for the year 6s they're very familiar with part whole models. So I've started by putting the total at the top, and then I've split it into the parts of this number. So I know this digit here, this 2, represents 2,000. And I know the 7 here, which would be in the ones column, represents 7 ones. So that leaves me thinking about this missing number. What could this be? Okay, well I've got those two bits. So it's this in the middle here that I've got to think about. Now, that's not 36. If we think about our place value, because it could be very easy to think, oh, that's 36. But actually, and again, children, you're very used to drawing place value charts nice and quickly, like I am. Let's pop this number on a place value chart. Now, we know that 3-digit represents 3 hundreds. And we know the 6 represents 6 tens. So the number that I've got left in my part whole model, my missing number is going to be 360. Okay, well done everybody that used their place value knowledge to spot that one. Okay, number 4 then. Oh, I'm going to be intrigued to see how many of you can remember the properties and can recall your knowledge of shapes. So, what is the name? So, we want to know the name of this irregular polygon. Okay, well, let's think about what is a polygon. Can anybody remember? What is a polygon? Well, a polygon is a shape with straight sides. So all the sides will be straight. And if all the sides and internal, so that means inside, so if all the sides and the internal angles, the angles inside of the shape, are the same, it is a regular polygon. So let's have a look at what that means then. Okay, I've got a regular 5-sided shape here. Okay, so it's all the sides are straight. Sorry everybody, that little bit of grammar is bugging me there, especially because we did subordinate clauses. Some of you are doing them this week. So, sorry, a polygon is a shape with straight sides. And if all the sides are the same, so these all, if we were to measure them, they'd all be exactly the same. And all the internal angles, so that's the angles on the inside of the shape, if they are all the same, then it is a regular polygon. So the question says about an irregular polygon. So what is an irregular polygon? Well, let's have a think. What do we know? An irregular polygon is when the sides and, let might not be both, but it could be one or the other, or it could be both. Okay, if the sides and or the internal angles are different, that means they're not the same size, then it is an irregular polygon. So let's have a look then. They're telling us this is an irregular polygon. So the sides are different lengths. These here are different lengths to these lengths. And the angles inside of the polygon are all different. Okay, so what is the name of this shape? Well, let me think about what else I could see here about this shape. Let's see how many sides it's got. So we've got 1, 2, 3, 4, 5 sides. So what do I know about shapes with 5 sides? What are they called? You're absolutely right, they are called a pentagon. So a 5-sided shape is a pentagon. And this is an irregular pentagon because all the sides and all the angles are different. Okay, Year 6, that concludes then our arithmetic learning for today. Don't forget to share your successes with me on Class Dojo. But more importantly, if you've done a bit of editing today, so you spotted a calculation mistake that you've made and you've gone back and edited that, I'll be really, really interested to see that, because that is the sign of a fantastic learner. Learning isn't just about getting everything right. Okay, of course, if there's one you struggled with or you're not sure about, also send me a message because I will do my best to help. Okay, have a wonderful Wednesday, everybody. It's nearly the weekend. We're getting closer, aren't we? Okay, see you tomorrow.